Is cross-curricular teaching advantageous when teaching maths and science? This presentation will address the debates regarding the teaching of maths and science in a cross-curricular way and how advantageous and disadvantageous this approach is in the primary school environment. I will also look at the practice of cross-curricular and the pedagogical decisions that are made when developing this approach. Although maths and science are discrete subjects in the national curriculum, is a largely discrete approach necessary? This presentation will be focused on the clear links between these two core subjects that have dominated, especially maths, the primary curricula, and show examples of how these links can be manipulated within the classroom. I will also address the debate of ICT within the classroom and the issues and benefits of it being used as an e-learn tool to enhance children's learning. History of cross-curricular ideas. The Plowden Report of 1967 promotes a keen idea for an integrated curriculum, a holistic approach, and learning through discovery. As Maguire 2006 suggests, Plowden Report was a keen supporter in the cross-curricular learning, greater parent involvement, and more classroom discovery activities. The National Curriculum of 1987 saw the division of the curriculum to more discrete subjects, making integrated and topic work much more difficult to conduct. Gillard 2008 saw the exposure of discrete subjects as making integrated work almost impossible. The Excellence in Schools legislation in 1997 saw the dominance of numeracy and literacy being solidified in the classroom, with each being taught for 1 hour every day. The Rose Review promoted the establishment of cross-curricular subjects and saw a rich cross-curricular idea as one that is beneficial to children. He stated that the new national curriculum framework proposed for 2011 would make the connections between more explicit and make planning more manageable. What is cross-curricular teaching? A way of organising the curriculum, draws upon similarities between subjects, inquiry-based learning, thematic work, project work, and integrated curriculum. What is cross-curricular? Cross-curricular is defined by the Collins Dictionary in 2015, denoting or relating to a subject to a topic that includes contributions from several different disciplines and viewpoints. Craft 2000 refers to cross-curricular teaching as possibility thinking, which is further supported in the Rose Report of 2006 that states that subjects will be complemented by worthwhile and challenging cross-curricular studies, allowing them to use and apply their subject knowledge across the curricula. Both Craft and Rose highlight the importance of developing basic mathematical skills through the national curriculum. However, we must also criticise Craft and Rose as to how far subjects can be integrated before they lose their contextual purpose. Thematic or project work can often lead to several subjects being absorbed into one topic theme, and in some cases, unnatural links begin to occur to compensate all subjects. Alexander, 1992, suggested that cross-curricular topic work risks diluting children's understanding of important concepts, meaning that geographical, historical, and various other subject skills are being lost to the effects of mathematical and scientific skills. Greenwood 2012 opposes the Rose Report and Craft by saying that teaching through cross-curricular approach or project-based teaching could lead to subjects such as maths and science being forced together by links that are not naturally there, making relationships between subjects much more contrived. To be discrete or not to be? That is the question. Should science and maths be taught from a discrete or cross-curricular approach? Some subjects naturally complement each other. Rowley and Cooper 2009 stated that we need math skills to learn science. Rowley exposes the issue that we cannot effectively work scientifically without having the fundamental basics of the mathematics. Science and mathematics connect through natural partnership, and so it is essential that these two subjects are taught through a cross-curricular way to strengthen the basic skills of each subject. It seems much more efficient to teach these subjects together in terms of time management and engagement. Symbols, numbers and graphs enable the children to express their ideas of science, and also allows them to explain their findings, and so mathematics play an admirable part in the understanding of the world and science. Henry 2012 stated that early and counting are intrinsic to their understanding of the world, which they engage with as a scientist. This shows us the clear link between the two subjects, showing that without mathematics we cannot understand the fundamental basics of life. However, Jarvis 2009 goes against Rowley and Hendry and suggests that teachers require carefully designed professional development, and so teachers should be sound with their subject knowledge in mathematics and science to teach effective cross-curricular lessons. Often when teachers create their own integrated units of study, the theme chosen is not based on mathematics. Instead, mathematics is integrated into the units of study from other disciplines, and students are often asked to count, add, sort, and make graphs. As Mayer, Cobbs, and Nicole in 1998 highlight, although these subjects are central elements of a primary level, mathematics are easily added to many integrated units. The mathematics involved is not challenging and narrowly focused. However, Barnes suggests that if children are unable to practice mathematical skills through other subjects, it will be more beneficial for them than an hour-long numeracy lesson every day, so they are constantly perfecting their numeracy skills. But Davies, 2011, suggested that in many primary schools, English and mathematics are considered too important to be fully integrated in the cross-curricular approach, which, of course, retaining their status as morning subjects. To finish, it would be with Hurley, 2011, who suggests that the study of cross-curricular approaches, she concluded that if two subjects were taught with intended equality, then achievement in science was much more higher. Discrete or not to be discrete, that is a question. Berlin and Hayoung, 2005, said the two disciplines are typically viewed as logically connected, meaning, as stated in the previous slide, these subjects connect naturally through a natural bond. However, Stinson 2009 say that if mathematics and science integration is desired practice in schools, then teachers must have a strong sense of what it means to have this integration happen. This study also points to the ongoing concern of teachers' content knowledge. The teachers need to have the passion for an integrated approach and know how to approach this subject with confidence. Although, as Berlin suggests, science and maths have connecting contextual value in many ways, we must make sure that teacher subject knowledge and passion must be on form for accurate work. Pincock argues that against Berlin, illustrating that although aspects do occur between the two subjects there, they should also be taught discreetly, as Mayer et al. Suggested, because the mathematical skills are often reduced. However, Kelly argues that the cross-curricular teaching improves pupils' motivation and engagement, as learning is placed in context that is both interesting and relevant to the learner. Numbers, graphs, and measurements are integral parts of mathematical skills and are essential within scientific investigation. Morrison and McDuffell, 2009, state that current recommendations in science and mathematics education call for more attention to inquiry approaches and working with science data, complementary areas for learning. Maths and science, clear links. Gardner 1983 says it's perhaps easier to see the links between science and maths rather than science and literature, saying that they are the same part of the same mathematical intelligence. Woolpart 1992 said that some science claim that mathematics is the language of nature itself and it provides a mirror of the physical world. Key Stage 2 Science Maths Investigation. Maths and science, an engaging concept that draws upon both scientific and mathematical skills, is the study of how best a plant can grow. For example, children can use their skills of fair testing and controlling variables to see which conditions is best for the plant to grow, but also use their math skills to see how high the plant grows using a ruler, which is reading numbers, and using tables to visualize represent their data, so they could put the different conditions down and the variables to record their data, and ordering and comparing these numbers by finding the mean and the mode to find out the average of the growth. During this investigation, children will be able to combine both scientific and mathematical skills and will draw upon skills learned in both discrete subjects, including measuring standard units, fair testing, and organising and comparing data. When conducting an experiment like this an organisation decision I would make is to have all the groups mixed up in so a wide variety of abilities are within each group, making the test fairer but also much more equal. I will do this because there has been hot debate on how children were set in terms of ability and how this can harbour their progress. This encourages them to communicate, aid their peers, develop self-esteem and investigate that through engaging content, but also help them develop controlling variables, fair testing, making scientific observations and using tables to represent the data. ICT in the classroom in relation to maths and science. Bransford et al. In 2000 said that computer-based technology can provide pedagogical skills that can extend our human capabilities. Lovelace goes against Bransford and says that IT skills that introduce children to a set of specific techniques are limiting and soon redundant. Sutherland et al. In 2009 suggests that teaching of graphs in science is limited by paper-based activities. The National Curriculum documentation links data handling with mathematics and science. ICT can be an extremely sufficient tool in both science and maths because it allows us to demonstrate our results in a clear and precise way. In many ways, should we not learn how to plot a graph and draw a statistical graph ourselves? Lovelock criticises Sutherland and states that ICT skills that introduce children to a set of specific techniques are limiting and soon redundant. This highlights the issue that ICT is ever-changing and children can be taught specific ways of displaying data handling, and within years this skill can become redundant. Watson criticised Lovelace by saying effective use of IT in cross-curricular will support the individual teacher's understanding of and willingness to experiment. It is not about techniques but what ICT can bring in terms of resources and presentation. Leask and Meadows 2000 highlight the importance of using IT as a key element of investigating science, and we can use data log etc. to help us gather data. Use it during lessons. They argue against Lovelace and express the idea that technology can play a vital part in capturing data. The 2000 English Natural Curriculum stated that all pupils should develop the key skills of using ICT. In conclusion, when looking at the overall benefits, we can observe that cross-curricular teaching does enhance children's learning considerably in many aspects, from social, cognitive development to intellectual development. When maths and science are taught together effectively, they reinforce both scientific and mathematical skills, improves learning, children's interaction with lessons, and allows learners to develop their mathematical skills considerably. As Kelly 2012 highlights, cross-curricular teaching improves pupils' motivation and engagement, as learning is placed in a context that is both interesting and relevant to the learner. The Plowden report also strengthens this idea, stating that knowledge does not fall into neatly separate compartments, and so a cross-curricular approach should be used to make lessons much more interactive. However, we need to be cautious of cross-curricular teaching in some cases, as Kelly and the Plowden report have missed. Alexander 2012 argues that cross-curricular topic work risks diluting children's understanding of important concepts. Cross-curricular and topic work is becoming ever more popular in the classroom environment. New teaching and modern ideas have changed the traditions of didactic teaching, and a new era has begun.